Light is one of the most familiar experiences in our world, yet it holds some of the greatest mysteries in the universe. Every second, trillions of particles called photons rush across the cosmos. Some have been traveling for billions of years, journeying through the vastness of space, slipping past stars, planets, and galaxies, carrying with them stories from the farthest reaches of the universe. But there's a question that's puzzled scientists for a long time. Can these particles of light exist forever? Are photons, the very fabric of light, eternal, or do they have a lifespan like everything else in the universe? To answer this, we must first understand what photons really are. Light, as we know it, is made up of these tiny particles, but they are unlike any other particle we encounter in the universe. Unlike objects with mass, like protons or electrons, photons have no rest mass. This means they're never still. They are always in motion, zipping through space at the speed of light, an incredible 186,000 miles per second. If you could hitch a ride on a photon, you'd travel around the Earth 7.5 times in just 1 second. But the most remarkable thing about photons is that, in their world, time doesn't pass the way it does for us. From the photon's perspective, the moment it is created and the moment it reaches its destination happen simultaneously. To a photon, the universe is frozen, just a single point, no matter how far it travels. But these humble particles of light are more than just fast. They are essential to life as we know it. Photons are the carriers of electromagnetic force, one of the 4 fundamental forces of the universe. It's photons that allow atoms to interact, creating the bonds that hold matter together. Without photons, there would be no light, no heat, no way for the universe to communicate its secrets. In fact, the entire electromagnetic spectrum, from the radio waves that carry your favorite song, to the X-rays that allow doctors to see inside your body, to the gamma rays that blast from exploding stars, is made up of photons. Whether you're heating up food in the microwave or staring up at the stars on a clear night, photons are at work, revealing the world to us. But the role of photons goes far beyond what we see. For scientists, photons are like cosmic messengers. They bring us information from distant parts of the universe, sometimes traveling across space for billions of years before reaching our telescopes. A single photon from a distant galaxy can tell us about the age of that galaxy, its composition, and its distance from us. These tiny particles have allowed us to map the universe, revealing the structure of stars, galaxies, and even the faint glow of the cosmic microwave background, the leftover light from the Big Bang itself. Now, imagine a photon's journey. Born deep within the core of a star, where nuclear fusion burns hotter than any furnace on Earth, a photon begins its long voyage. But it doesn't leave the star right away. Deep inside, photons are trapped in a chaotic dance, bouncing off particles, changing direction, colliding again and again. It might take thousands, even millions of years for a photon to escape the core and reach the star's surface. Once free, the photon shoots off into the vastness of space, traveling at the speed of light, unimpeded by time or distance. As this photon hurtles through space, it crosses unimaginable distances, passing planets, stars, and clouds of cosmic dust. Its journey might last millions or even billions of years, until one day it reaches Earth. It slips into our atmosphere, bouncing off molecules of air, and perhaps, after all that time, it reaches your eye. In that instant, your brain decodes its message, a photon's journey across the universe, now visible to you. That little particle of light carries with it the story of its birth, the distance it has traveled, and the star or galaxy it came from. In that brief moment, you are connected to the cosmos in a profound and almost magical way. But despite this incredible journey, scientists have begun to ask, can photons keep going forever? Could these particles of light, which seem so stable, eventually fade or decay? Current physics tells us that photons are incredibly stable. Once created, they can travel for billions of years without changing. But what if that's not the whole story? Some theories suggest that photons might not be eternal after all. What if, over immense stretches of time, photons could decay into other particles? One idea is that photons could eventually transform into something called axions, tiny, hypothetical particles that may help explain the mystery of dark matter, the invisible substance that makes up most of the universe's mass. If photons decay into axions, it could explain why we have such a hard time detecting dark matter directly. But here's the catch. We haven't found any evidence yet that this happens. All the photons we observe, even the ones from galaxies billions of light years away, seem just as bright and intact as when they were first emitted. Still, this question of whether photons can decay is more than just a curiosity. Scientists are actively searching for answers at places like the Large Hadron Collider, the world's largest particle accelerator. Physicists are smashing particles together at nearly the speed of light, producing high-energy bursts that include showers of photons. By studying these interactions, they hope to detect any signs that photons might decay or behave in unexpected ways under extreme conditions. So far, these experiments have supported the idea that photons are stable, but the search continues. And that brings us to one of the strangest aspects of photons, their quantum nature. You see, in the world of quantum mechanics, particles like photons don't always behave the way we expect. Photons exhibit something called wave-particle duality. This means that sometimes they act like particles, tiny discrete packets of energy that travel in straight lines. But other times they act like waves, spreading out and interfering with each other, creating patterns and effects that are nothing like what we experience in the macroscopic world. This wave-particle duality was famously demonstrated in the double-slit experiment. When scientists fired photons through two narrow slits, the photons created an interference pattern on a screen behind the slits, as though they were waves passing through both slits at once. But when they tried to measure which slit the photon went through, the interference pattern disappeared, and the photon behaved like a particle again, as if it knew it was being watched. This bizarre behavior, where photons seem to exist in multiple states at once, challenges our classical understanding of reality. But that's not the only strange thing about photons. They can also be entangled. When two photons become entangled, their properties become linked, no matter how far apart they are. If you change the state of one entangled photon, the other will instantly change too, even if it's light years away. This phenomenon, known as quantum entanglement, has baffled scientists for decades and continues to push the boundaries of our understanding of space and time. As if that weren't enough, photons also interact with the universe itself as it expands. As space stretches over time, so do the wavelengths of photons traveling through it. This effect, known as cosmological redshift, causes light from distant galaxies to shift towards the red end of the spectrum. It's one of the key pieces of evidence for the expanding universe. The farther a galaxy is, the more its light is redshifted, showing that the universe is not static. It's growing, stretching like a giant cosmic balloon. And, as photons ride along with this expansion, their energy diminishes, but they keep going, carrying with them the story of the universe's growth. But not all parts of the universe are peaceful places for photons. In some regions, particularly near massive objects like black holes or neutron stars, photons face extreme conditions. Black holes, with their immense gravity, can trap light itself. Once a photon crosses the event horizon, the point of no return around a black hole, it can never escape. Its story is lost forever, swallowed by the black hole's insatiable pull. Neutron stars, on the other hand, are so dense that their gravity can bend and warp the path of photons. These stars also have incredibly strong magnetic fields that can cause photons to interact in unusual ways, sometimes even splitting into particle-antiparticle pairs for brief moments before recombining. These extreme environments show us just how flexible and strange the behavior of photons can be. As scientists continue to study photons, new technologies are being developed to push our understanding even further. Instruments like the James Webb Space Telescope are designed to capture light from the farthest reaches of the universe, revealing more about how photons behave in the wildest corners of space. Quantum experiments and particle colliders are helping us unlock the deeper mysteries of light, exploring whether photons are truly as stable and eternal as we think. And so, we find ourselves at the edge of a cosmic mystery. Photons, those tiny, tireless travelers of light, have taught us so much about the universe. They have shown us the birth of stars, the collapse of galaxies, and the very beginning of time. But the question remains, can photons last forever? Are they destined to carry the light of the cosmos indefinitely, or will they one day fade, leaving behind a dark and silent universe? For now, the answer remains elusive, a puzzle waiting to be solved. But one thing is certain. As long as there is light, as long as there are photons, they will continue to guide us through the mysteries of the universe, one beam of light at a time.